Okay, welcome back students. So in this video we'll be doing question number 2 of section B. So this is the question which is given to us. Okay, we're asked to find the LCM and the HCF of the pairs. So the way to go about this is actually, I'm pretty sure if you have watched the previous video or if you are thorough with the previous exercise, we've learned how to find out HCF, right? Exercise 1.1 dealt with that. But we were asked to find HCF using Euclid's division lemma, yes? Okay. But here, there's another way for finding out the HCF, okay? It's given here. We're using it by prime factorization method, okay? For both the cases, even for the next case, I'll be just using that. Now, HCF is actually the product of the smallest common factor, okay? Or you can just say this is the common factor between the two numbers, okay? Factor between the two numbers, okay? Between the two numbers. You'll always have to compare between two numbers, right? And when you talk about least common multiple, so this is highest common multiple, so which is a factor, a common factor between both the two numbers, all right? And when we talk about the least, that is the LCM, we're talking about the product of the greatest power, all right? So the greatest power of each of the prime factorization, okay? Prime factorization. So I don't think we need much explanation for this. Once we start doing the problem, you'll have a better idea. But just remember, HCF is basically the common factor which is between the two, and LCM is the product of the greatest power of each prime factorization, okay? So we're not just talking about one prime factorization, we're talking about both the prime factorization, or the amount of numbers that is given, all right? Because sometimes you may be asked to find the LCM, the HCF of not just two numbers but 3-4 numbers, so depending on that, okay? So even depending on that, HCF would basically mean the common factors between the numbers. It could be 4-5 numbers, so the common factors, and LCM is going to be the product of the greatest power of each prime factorization. We'll just do the problems and I think you'll be able to get it. So first, let's take a prime factorization of 26. Now we know that 6 is a multiple of 2, so you can always multiply it. You can always begin with 2. So 2 into 13 gives you 26. Now when we talk about 91, I think a 7 into, no, not really 7. There's 7 into 13, I think. 13 into 7, yes. 7 into 13 gives you 91, because 7 is also a prime number and 13 is also a prime number, right? So the HCF, the common factor of 26 and 91, so the common number that you can see for both the cases is 13. So by default, HCF of 26 and 91 becomes 13. Next is you have to find the LCM. Now if you remember, LCM is actually the product of the greatest power of each prime factorization, okay? So you'll actually have to take the prime factorization of each of these two numbers. So let's go with 2. 2 is not present here, so you'll have to take 2, all right? And the highest power over here is 1 itself. Next is 13. Both has 13, so you just consider only 1, okay? We're only going to be considering with the highest power. In case, okay, I'll just give an example. In case if this was 13 square, so we'll have to be taking it as 13 square, because when you compare 13 and 13 square is actually the number with the greatest power, right? Or it is the prime number with the greater power, okay? So we'll be taking 13 square, but in the case of this, it's just 13, so we'll only be taking 13, and then you have 7, okay, into 7. So when you take a product of 13 into 6, 26 into 7, it will give you 182, okay? Right? So next thing, we're actually asked to verify if LCM into HCF is equal to this. So you can always write this as verification, okay, since we're trying to verify. So we're asked to verify if LCM into HCF is going to be equal to the product of the two numbers, okay? I'll just write this down, product of the two numbers. So the LCM is given as 182, okay, and HCF is given as HCF is given as 13. Now the two numbers that we are dealing currently is with 26 and 91. So 182 into 13 actually gives you 2366, and 26 into 91 also gives you 2366. Okay, so this is how you get. So for multiplication you'll have to do, okay, in order to save time, I'm just not doing the calculation, but I hope you understand, right? 6 into 1 is 6, 9 into 6 gives you 54, 2 into 1 gives you 2, 9 into 2 gives you 18, so you're left with 6, 8 plus 5 gives you 3, 1, so 2, 3, 6. The same goes for 182 into 13. Okay, so we have verified it, we have found out the HCF and the LCM. Now quickly moving on, we'll go with 510, this, okay. So 510, since it's a multiple of 5, I'll straight away go with 5. So 5 into 1 time and 5 into 12. Next is 5 into 3 into 4, right? So this can be written as 5 into 3 into 2 into 2. Or you can rewrite it as 5 into 3 into 2 square. Remember, you cannot write it as 4 because 4 is a it's a composite number. So prime factorization, you're always allowed to write this way, okay? Instead of 9, you're supposed to write it as 3 square when you're asked to write a prime factorization of any number. Next, let's go with 32, okay? 5, okay, sorry, it's not 5 into 12. Okay, it's not 5 into 12. It's a mistake. 5 into 12 is only 60. It's 510. It's actually 5 into 102. Okay. So next, you can always, since this number ends with a 2, you can always multiply it with 2. 2 into 5 times 1, and then 5 into 2 into 3 times 17 gives you 51. So the prime factorization is 2 into 3 into 5 into 17. Clear? Now quickly moving on, we need to take it as 2 into 46. Okay, so you can just break it down slowly this way. Okay, 2 into 23. Okay, so this is going to be 2 square into 23. Now let's go for the HCF of 510 and 92. So if you really look into this prime factorization, what is the common factor? What is the common number that occurs between this? It's actually only 2 alone, right? Because this 2 square is also just, it's actually 2 into 2. So the only number that is common to both is 2. Okay, it cannot be 4, remember that. Okay, it cannot be 4 because over here you don't have 2 into 2, you only have 2 alone. Okay, if this was 2 into 2, suppose, then you can take it as 4, but there's only 1 2. So the only common factor here is just 2 alone. Okay, just keep that in mind. Next is LCM. Okay, so the LCM is we're supposed to take the product of the highest power. So now see, this is a good example. You look at 2, you're supposed to take the product of all of these numbers. Okay, when we talk about LCM, so 2 and 2 square, which of these prime numbers have the greatest power? It's actually 2 square, right? So you'll have to only consider 2 square. So since you've already considered 2 square, you don't have to now take this alone, okay, because we only consider the product of the greatest power of each prime numbers. Next, you'll have this as 3 into 5 into 17 into 23. So when you take a product of all of this, you'll be getting this as 23,460. Okay, clear? Now quickly moving on, we'll try to find out the verification step. Verification, which tells us that the LCM into HCF is equal to the product of the two numbers, which is 510 into 92. LCM is given as, what did we find out for LCM? LCM is 23,460. The HCF is 2. Okay, so let us check if 23,462 into 2 is equal to 510 into 52. So we're getting this as 46,920. Now let's just check for 510 into 92 is also the same thing as 46,920. So we're done with the verification. Okay, so this way we know that our answer is correct. All right, next question, we have this. Okay, we'll first find out the prime factorization of 236. Now since this number again ends with a 6, you can start with 2. Okay, so 2 times, or let's go with an easier one, let's go with 3. Okay, because as you can see, 3 is both, 3 times 1 is 3, 3 times 1 and 3 times 2. Then after that you can start working with 2. 2 times 5 gives you 10, 2 times 6 gives you 12. So 3 into 2 into, so in fact 8 into 6, right? 8 into 6 gives you 56. Okay, so this way we can always write this as 3 into 2. 8 can be written as 2 cube and 6 can be written as 2 into 3. So the prime factorization of this is going to be 8 7, sorry, it's not 6, okay, 8 7, 2 cube into okay, 2 into 7, 8 7 gives you 56. Alright, so you take this, it can be written as 2 times 4 into 3 into 7. Now let's go with 54. 54 can be written as 6 into 9. So this can be written as 2 into 3 into 3 square. So this can be finally written as 3 cube. So let's check first the HCF. Okay. So HCF should be a common factor. So let's see, 3 is also here. So you can write 1 3. Only 1 3 is present in both. So you only have to consider that. The same thing goes for 2. There's only 1 2 over here. There are 2 4 times, right? There are 2 2 2 2 2 4 times, but over here it has only 1 time, so you just have to only consider 2. So the HCF is going to be 6. Now when we talk about the LCM of 336 and 54, what is the highest power between these? Both of them have 2 and 2, but what is the highest power for this prime number? The highest power that the prime number 2 has is actually 2 to the power 4, so you're supposed to consider 2 to the power 4. Now for 3, what is the highest power over here? 3 cube, okay, into 7. So when you multiply this, you can always open up the bracket. So this will give you 16 into 27 into 7, and the answer for this is going to be 3000. Let's see, 27 into 6 into 7 gives you 3024. Okay, so let us finally move on with the verification. So verification is we have to consider LCM into HCF and the product of the two numbers. Okay, product of two numbers. So the LCM, we got it as 3024, HCF we got it as 6. The product that we are currently discussing is 336 into 54. Okay, so 3024 into 16 actually is 8 into 6, right, is 18,144, and the product of 336 into 54 is again 18,144. Okay, so this is how we do the verification purpose. So we shall end the video here.